Welcome to the new video. So today I am going to start solving the OPSC PGT paper 1 2025, and the exam was done recently, and let me solve some of the problems. Actually, I am going to solve all the problems here in my channel. So today we will start from question 1, and the question level is easy, easy to moderate, I will say. uh, for a PGT level student, it will be easy, I guess. So let's start with the questions. Okay, and most of the questions, while looking at the problems in the paper, I noticed that most of the questions are from previous year gate or net papers. Okay, so do not escape the mock related to gate or CSR net. Okay, so it's very important to solve all the PYQs, okay, before going to give any kind of exams uh, on your merit. You can attempt all the questions, but if you have solved the PYQs, it will be easier for you. Okay, so let's start with the question number 1, and this is the instruction bagara, and this question is not mine because I haven't appeared in the exam. So this question is someone else, and I have uh, I have take his questions to solve and to let you know what are the correct answers. Okay, so let's start with the first question. The first question is saying, which of the following magnetic vector potentials gives rise to a uniform magnetic field B0 k cap? Okay, so actually it is the question is about the correct vector potential. Actually we have to see what the question is asking us. So vector potential, you have to know what is the relation between the vector potential and magnetic field. So we all know B vector is equal to curl of A. So by using this relation, we could see which of the option is correct. Okay, let's look at it. Let me add a page so that we could solve. Okay, so in the first option, it is about the first option B0Z k cap. Let me see. A vector is, the option 1 is B0Z k cap. Okay, this is the option 1. Let me check. Call of A should be some non-zero quantity. Let me check. I cap, J cap, K cap, dou by dou x, dou by dou y, dou by dou z, and we have K cap component, so Ij is 0, so we have only B0Z. If we solve I cap dou by dou y of B0Z, so it is 0, minus dou by dou z of 0, so it is also 0, plus J cap, we have dou by dou x of B0Z cap 0, dou by dou z of 0 is 0, plus K cap, we have this is also 0, so we have 0. So option A can be the answer. So option B, let's see what option B is saying. Minus B0xj cap, minus B0xj cap. Let me check this. For the choice of vector potential minus B0xj cap, call of A will be equal to I cap, J cap, K cap, dou by dou x, dou by dou y, dou by dou z, and we have J cap component, so 0 minus B0x and 0. So determinant will be I cap will be 0, plus J cap will be also 0, plus K cap, we have dou by dou x of minus B0x, so minus B0 minus 0, so we have minus B0 K cap, so it is non-zero. This could be a answer. Let me check the other options also. Option C is B0 by 2 minus y I cap plus xj cap. b0 by 2 minus y I cap plus x j cap. Okay, is it the option? Yes. Let me check it also. Call of A will be I cap, j cap, k cap, dou by dou x, dou by dou y, dou by dou z, and this is I cap is b0 by 2 minus is there y, and b0 by 2 x, and this is 0. So I cap will be 0 plus j cap will be 0 plus k cap will be dou by dou x of b0 by 2, so that will be b0 by 2 only, minus dou by dou y of minus b0 by 2 y, so this will be plus b0 by 2, and we are getting b0 k cap. Okay, if you will see b0 k cap, so in our question it is asking the magnetic field should be b0 k cap, and from option C we can see we are getting my b0 k cap. Okay, so this could be the right answer. Okay, and you see what that person do here is he just check if from the given option what is my correct value for non-zero magnetic field, and he got B option, so he choose that as his answer. But you have to see it is given that we have to choose the magnetic field such that it will be B0 k cap. Okay, so from option C only I am getting the positive B0 k cap, so option C is the right answer. Okay, yes. And then so the question number 1 is option C is the correct answer. So let's see question number 2. What is question number 2 is saying? In question number 2 we have given that E vector is E0 cos kz minus omega t I cap. We have given to find out pointing vector. So we know pointing vector, for the pointing vector we denoted it as S is equal to 1 by mu naught E cross B. Okay, and we have given E vector. E vector is your E0 cos kz minus omega t I cap, isn't it? Yes. And let me find out what is B vector, because from the formula we know S vector is 1 by mu naught E cross B. So I need to find out B vector. B vector is nothing but E vector by C. So it will be E0 by C and cos kz minus omega t. And remember, when we are doing the cross product we have to take care about the direction. Okay, so it will be j cap because we'll get S vector in the k cap direction. So when I will do the cross product, 1 by mu naught E0 square it will become, then cos square kz minus omega t, and I cross j is k cap. So here and one more, so this could be the answer, but from the option we have here epsilon, so we have to think about the relation where C is related to mu naught epsilon naught. So how does it relate? We know C is equal to mu naught epsilon naught root over, so you can write C square is equal to mu naught epsilon naught. So you can write mu naught C is equal to nothing but 1 by, so C square is equal to 1 by mu naught epsilon naught. So I can substitute here and I can get the answer as 1 by mu naught C. So mu naught C you can write as your C epsilon naught E naught square cos square kz minus omega t k cap. Okay, is it clear? Yes. So this is the correct answer, option number A. Option number A is the correct answer here. Okay, question number 3. question number 3 is talking about, let me add a page. Okay, in question number 3, if you see, question number 3 is asking, a plain electromagnetic wave traveling in free space is incident normally on a glass plate of refractive index 3 by 2. If there is no absorption by the glass, its reflectivity is how much? Okay, as I have earlier mentioned that most of the questions are from the previous year questions of GATE and CSR NET. This one is asked in GATE 2012. You can check. This is the question of GATE 2012 exact question, exact options. I think I can show you, but let me just, you can also check it later. Okay, so let us solve this. So it is asking us about the reflectivity. What should be the reflectivity? We should know the formula for reflectivity from electrodynamics. We know that n1 minus n2 n1 plus n2 whole square is the reflectivity when there is no absorption. For we have n1 is 1 as here, and n2 is the glass medium, and it is given 3 by 2 is the refractive index. So this is refractive index of glass. Just put it here, 1 minus 3 by 2, 1 plus 3 by 2 whole square. This will become minus 1 by 2 square divided by, this will become 5 by 2, 5 by 2 square. So it will become 1 by 4, 4 upon 25, so 1 by 25. So we have to give the answer in percentage. So it will become 1 by 25 into 100. So 4% is the correct answer. Okay, how easy it is. Okay, so option number A is the correct answer. And next question is a little advanced level question. Okay, this is from MSc level, we can say. This is linear Wishart potential. So I have take reference from the book J.D. Jackson, and I will explain what is we mean by the linear Wishart potential. Actually, the charges moving with some velocity comparable to speed of light, there only we see the linear Wishart potential. I have take the reference from the book J.D. Jackson. You can refer to that also. Actually, the linear Wishart potential are used when the conditions will be satisfied. The charge is moving relativistically, that I have mentioned, that with a velocity close to the speed of light, and the charge may be accelerating or deaccelerating. Okay, so basically the answer here, we have to look at the options. What is the appropriate option here? So this question is also asked in 2007 GATE paper. If you can also refer to it. The point charge is highly accelerated. It is not appropriate. There is something missing. Okay, the electric and magnetic fields are not perpendicular. This can't be the reason. The point charge is moving with velocity close to that of light. Yes, this is the possible option. The possible answer may be this. Let's see the option D. The calculation is done for the radiation zone that is far away from. This is not the appropriate reason for the linear Wishart potential. So the correct option is option number C. That is relativistically. It is related to something relativistically. So speed of light is the moving charge. Moving charge, the velocity will be close to your speed of light. And this is a very simple question, you can see. So the Maxwell equation which describe the non-existence or absence of magnetic monopoles, we know the second law of Maxwell, that is del dot V is equal to 0. Okay, there should not be any confusion in here. And the 6th number question is about the dispersion relation. It is asking us the relation between Vp and Vg. So first of all, we have to know what is the expression for Vp and Vg. We know Vp is generally omega by k, and there is also one relation E upon P, as here omega and k is the dispersion relation between omega and k is given. So we have to we have to take the help of the relation Vp is equal to omega by k. Sometimes the dispersion relation is given as E and P relation, so you can also use this in that scenario. And Vg is nothing but d omega by dk. So let's do this calculation. So we have the dispersion relation as omega square is equal to omega naught square plus c square k square, where omega naught is a constant. So let's take derivative on both sides. So this will be 2 omega d omega of 1 dk. This is 0. This will be c square. If you do the derivative, you will get 2k only here. So this will be 2 cancelling on both the sides. So d omega of 1 dk is nothing but c square k. So it will become d omega by dt is Vg and c square k. Vg is equal to c square k. And we have Vp is equal to omega by k. Okay, Vp is equal to omega by k. We can. So here I have missed omega. So omega Vg. So we can write omega upon k Vg is equal to c square. Omega upon k is nothing but Vp. Vp into Vg is equal to c square. So the appropriate answer here is option number D is the correct answer. Let me move to the question number 7. I think you all are enjoying this. Okay, so yes, it is a very important question. Yes, you have to be little conscious here. Simple question, but you have to be little careful here while solving this. You see the relation, uncertainty relation given is this. So we can't just use del x del p is equal to h cross upon 2. We have given the uncertainty relation, so we have to stick to this relation only. Okay, let us see how could we solve this. So the question is given the uncertainty in the velocity of a particle is equal to its velocity. Okay, so the uncertainty in the velocity, so del p I can write m del v. So del v is given equal to the velocity. Let's suppose the velocity is v, so del v is equal to v. So while writing del x del p is equal to h cross h, only h, it is given del x del p is h. So I can write del x m del v is equal to h. So I can also write del x m del v is given as v, so I can write v. I can write it as del x is equal to h upon mv, del x is equal to h upon p, and we know from the de Broglie wavelength concept h upon p is lambda. So I got the uncertainty in position as the de Broglie wavelength. So de Broglie wavelength is the correct answer. I don't know why he chose the de Broglie wavelength upon 2. Okay, let's excuses him. So we got the right answer as de Broglie wavelength is the correct answer. Okay, as far as I am concerned. So this question is a very important question, and it is little more thinkable question. I would say you can solve this from a trick. The short trick to solve this question is, you know, the relation, the commutation relation of position and momentum, that is xp is equal to ih cross. You just simply do one thing, you just put this relation, okay, and check every option, you can get the answer. Let me check the first option for you guys. Okay, so I have given ih cross dou by dou p as xp. So I will do the commutation with psi, and I know this will be ih cross psi. So let me open it off. If I will open this, I will get what I will get. ih cross is the constant, so I will take it outside. Dou of 1 dou p psi, okay, and I have p dou upon dou p psi, and the RHS is IH cross psi. I am only doing the LHS. Let me see if I am getting the RHS as it is or not. If I am getting the RHS as it is, then the option number A is the correct answer for me. So let me see. If you do the differentiation, you will get P dou psi dou P, and if you do dou P upon dou P, so you will get only psi minus P dou psi upon dou P. Okay, and we have, so you will get IH cross, this will get cancelled, we will only get psi. So the correct and I am getting this is the RHS. So I am getting option A as my correct answer. Okay, option A is your correct answer here. No, this option is wrong. These are wrong because here is minus sign. Okay. Okay. And the next question is the direct question from the book. The Dirac delta function delta x can be represented as. This is just the Fourier transform of Dirac delta function. If you do the Fourier transform of Dirac delta function, you could get the answer is this. This is your correct answer. I will give you the general expression for this. What is the general expression? You will get the general expression as 1 upon 2 pi minus infinity to infinity e to the power I k minus k naught x dx is equal to delta k minus k naught. This is the general expression. You could remember this. Okay. So question number 10, and this is going to be the last question of the session because the video will be go so long. So I want to make it make it short, but still it is above 20 minutes now. So let me solve this. So this question we have given the AB as two operators which commute. Okay, so let me solve this for you. Let me add one page. These relation we need to remember, but nothing to worry, we can solve also. Okay, so the question is we have to find out e to the power a into e to the power b. Okay, let me see how we can solve this. E to the power a into e to the power b. This is the question we have to find out the correct answer for this. Suppose I am taking f of lambda as a function, and it is a function of e to the power lambda a, e to the power lambda b, but lambda is a scalar quantity. So if I will do the derivative with respect to lambda, so I will get a e to the power lambda a, e to the power lambda b plus e to the power lambda a b, e to the power lambda b. Remember, these are the operators. These are operators. I am not giving the caps on all these things because while I am writing, I don't want to be a little. I don't want to get into a little time. Okay, so if you write a e to the power lambda a, e to the power lambda b, here we can do one thing, e to the power lambda a b, and I am writing here e to the minus lambda, e to the power lambda a, e to the power lambda b. So we can take the common here, a plus e to the power lambda a, b e to the power minus lambda a, and outside we have e to the power lambda a, e to the power lambda b. Okay, I hope till this point everything is clear. So we need to find out this e to the power lambda a b. So you need to expand this 1 plus lambda a plus lambda square upon 2 factorial a square plus lambda cube upon 3 factorial a cube plus dot 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 into v, and these are operators, remember. B plus lambda a b plus lambda square 2 factorial a square v plus lambda cube 3 factorial a cube v plus dot dot. We know the relation a to the power n b will be n a to the power n minus 1 a b. Okay, and if I will have to write it explicitly, we can write it also as a to the power n b b a to the power n is equal to n a to the power n minus 1 ab, and this will become a to the power nb is equal to b to the power a to the power n plus n a to the power n minus 1 ab. Okay, and here we can substitute here e to the power lambda ab will be equal to uh, n is an integer value. You can put 0 1 2 3 as you want, so we are going to put it here. So this will become lambda ba plus ab commutation plus lambda square upon 2 vector. Here you have to put a square b, so a square n in place of n you have to put 2, so put it ba square plus 2a into ab commutation, okay, plus dot 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 dot. So e to the power lambda ab will be equal and you know I am not writing this, the next addition will be lambda cube upon 3 factorial ba cube. Okay, in place of n you have to put 3 there, so 3a square ab. Okay, then what we have to do is, so we can write it as b e to the power lambda a plus lambda ab commutation e to the power lambda a. Okay, I just took the common. Okay, took the common from these terms, so you can get this. So e to the power lambda ab e to the power minus lambda a will be equal to b plus lambda ab. Okay, and what is the differentiation I got? Df upon d lambda, so I will just put it there. Df upon d lambda will be equal to now a plus b plus lambda ab, and outside I have f of lambda. Okay, so I will do the variable separable here. Let me add one page also here. Okay, okay, fine. So df upon f of lambda will be equal to a plus b lambda ab commutation into d lambda. Do the integration, we'll get ln of f of lambda will be equal to a plus b plus lambda square upon 2 ab commutation. Okay, so f of lambda will become e to the power a plus b. Now you see I got the relation. Okay, put lambda is equal to 1, so we will get, and f of lambda is nothing but e to the power lambda a e to the power lambda b. Now you have to just put lambda is 1, so you will get e to the power a e to the power b is equal to e to the power a plus b plus 1 by 2 ab commutation. Okay, is there any option? Yes, there is one option. So option number C is the correct answer for you. Okay, you see the proof. Okay, so for today I have done 10 questions. I have solved 10 questions. If you like the solutions, if you like the video, the way I am doing the questions, so do comment, and if there is any wrong in solving, you can also comment, or if there is other ways to solve the questions, you can also comment down, and you can also share your opinions. Okay, and how is your exam? If someone watching this video has given this exam, so how is your experience attending this paper? Okay, share with me, share with all the other viewers also. Okay, thank you very much.